Hey there students, welcome to math.serve.com. In this clip we're going to be going over part 2, problem 6 to 10 of the ACT math test prep. To gain access to this document, please go ahead and visit www.actstudent.org. Alright, let's take a look at question number 6. It reads, George's current hourly wage for working at Denti Smiles is $12. George was told that at the beginning of next month, his new hourly wage will be an increase of 6% of his current hourly wage. What will be George's new hourly wage? Now, you want to keep in mind, a caution as indicated here. When you're calculating percentage increase or decrease, you want to ensure that your percentage value is converted to decimals before carrying out your calculations. Okay, either decimals or fractions, whichever format. And another point you want to recall is that to convert a percent to decimal, that can be accomplished by moving the decimal point 2 places to the left, which is equivalent to dividing by 100. Okay? Alright, so let's go ahead and solve this problem. George's initial wage was $12 an hour, right? So just use 12 for now. And he's going to enjoy a percentage increase. And he's going to enjoy a percent increase of 6%. Now, in order for us to carry out our calculations, we have to convert this into decimal form. So we just simply move the decimal point forward to the left twice. Okay? So 6% becomes 0.06, or you can use 6 over 100. You accomplish the same thing. Okay, so his new wage is simply going to be his initial wage multiplied by 1 plus the percent increase in decimal form. Okay, this is the quickest way to carry out your calculation. Remember that on the ACT exam, there are 60 math questions and you have 60 minutes to solve all of them. So you basically have around a minute per problem. So you want to be as fast as possible when you're solving these problems, all right? So this is the fastest formula to help you solve the problem. Initial wage is 12 times 1 plus the percent increase in decimal form, which is 0.06. If it were a percent decrease, let's say he was getting a pay cut, you will subtract that percent decrease from 1. Okay, plus increase minus decrease. Okay, so simplify this further. You have 12 times 1.06. And just to save time, you can plug this into your calculator real quick, and you end up with 1272 as his new hourly wage. Your answer is option letter H. All right, let's take a look at problem 7. It reads, the first term is 1 in the geometric sequence 1, -3, 9, -27, and it goes on and on. What is the 7th term of the geometric sequence? All right, one thing you want to recall, to keep in mind concerning sequences, is that there are 2 types of sequences. We have geometric and arithmetic sequence, okay? Anytime you see the word geometric sequence involves repeated multiplication. Okay, you multiply by the same number over and over again. That number is known as the common ratio R. Okay? When you see an arithmetic sequence, this sequence involves terms generated by repeated addition. Addition by a common difference D. Okay, if D is positive, the sequence gets bigger, the arithmetic sequence grows. If D is if D is positive, the sequence grows, and if D is negative, the sequence falls. All right? So don't forget, geometric is multiplication and arithmetic is addition. Now this problem is a geometric sequence problem, so what's the growth pattern here? It's going to be repeated multiplication by some constant ratio. Now, I'm going to show you two ways of solving this problem. You can do this by repeated multiplication or by using the formula for the nth term of a geometric sequence. Okay, so let's take a look at the first method. Method 1. Method 1 is the repeated multiplication method. All right. So whichever one is faster for you, go ahead and use it. All right, so repeated multiplication method is as follows. We have the first four terms of the geometric sequence: 1, -3, 9, -27. So this is 1, 2, 3, 4. We need the seventh. So we need 5, 6, 7. So this is our target right here. So what do you notice happening over and over again? What do you multiply by 1 to get -3? You multiply -3. Okay? So since this is a geometric sequence, what do you expect? You expect that terms to be generated by multiplying by -3 over and over and over again. This is your common ratio. Okay? So -3 times -3. What should that give you? -9, as you can see is the case here. Okay, keep on going, times by -3 again. You get -27. So we can see that our pattern is in fact correct. Sometimes you might think that a particular number is a common ratio, but you have to test it for multiple terms to make sure that your hypothesis is in fact correct. Okay, now let's go ahead and generate 5, 6, 7, and term 7 will be our answer. So what am I going to do? Multiply by -3 again. All right, you can use your calculator for this. Here you're going to have 81, because -3 times -27 is 81. Multiply by 3 again. You end up with -243. Finally, multiply by another -3, and you end up with positive 729. The seventh term of this geometric sequence is 729, option E. Okay, this is a method of repeated multiplication. Now let me show you another method that you might have studied for solving this problem. Method 2 is using the nth term formula. Okay, the nth term of a geometric sequence. So in order for you to take advantage of this method, which is rather fast, you need to be able to recall what the formula is and what the different components mean. Okay, so the formula is as follows. Formula for the nth term of a geometric sequence, an is equal to a1 times r to the n minus 1. Okay, so to generate the seventh term, we need three ingredients. We need the first term, the common ratio r, and n. Okay, so since we're working with the seventh term, let's write that down. Since we are working with the seventh term, that implies that what? What does that imply? N is equal to 7. Okay? Now, the n is equal to 7. We know that the first term, a1, is given. a1 is 1. We need the common ratio. Okay? The common ratio can be accomplished by dividing a term by the term before it. So a2 over a1 or a3 over a2. Okay? General formula is an divided by an minus 1. So just pick any two terms, consecutive terms, and divide the term to the right by the one before it. So let's pick a2 and a1, all right? So -3 divided by 1 is -3. Or you can ask yourself, what constant value do I keep multiplying terms by over and over again to generate the next term? That's your constant ratio, which is -3. So we have the three components we need to generate the seventh term, which is a7. Using the formula, a7 is equal to a1, positive 1, times -3, raised to the n minus 1, 7 minus 1. So that yields -3 raised to the 6th power. You can plug this into your calculator. You end up with 729. Okay, so this is another way of solving the problem. All right, let's take a look at problem number 8. It reads, the shipping rate for customers of ShipQuick consists of a fee per box and a price per pound for each box. The table below gives the fee and the price per pound for customers shipping boxes of various weights. Okay? Question. Greg wants ShipQuick to ship one box that weighs 15 pounds. What is the shipping rate for this box? So this problem is assessing your ability to interpret this chart and carry out an accurate price calculation. Okay, so let's go ahead and write down the formula that's used to determine the price, the shipping rate for a box. Down, let's write it down, and then we'll see which row is applicable to Greg's situation. Okay, so shipping rate. What is the shipping rate? Well, there are two parts. First of all, let's look at this problem carefully. It consists of a fee per box. Okay, so fee per box, and so plus is for and, right? Price per pound. Okay, so what you simply do is you take the price per pound determined by looking at the amount of pounds you have and then going to this table, and then of course you're going to multiply the price per pound by the weight of your box in pounds. Okay, so this is the formula that can be used to calculate the shipping fee for anybody trying to ship with this company right here. Now, what's Greg's situation? Greg is shipping just one box, makes things easier, but the box weighs 15 pounds. Okay, so what column are we looking at? Are we looking at column 1, 2, or 3? What row, sorry. What row are we looking at? Which row is applicable to Greg's situation? Let's write it down. For one box, for a box that weighs weighs what? For a box that weighs 15 pounds, which is the case with John, we use the second row. Why do we use the second row? We use the second row because 15 is between 10 and 25. Okay, because 15 is between 10 and 25. So if your box weighs 10 pounds, 25, or anything in between, you're going to be using the second row to determine your fee and your price per pound. Okay, so in Greg's situation, this is the row that we're going to be using to calculate his shipping rate. Okay? All right, so let's apply this rule to this formula right here. So we have Greg's shipping rate is his fee, which is $10, plus what is the price per pound in that row? The price per pound in that row is 0.65 per pound. Okay, please be careful with that. We have to multiply by the weight of Greg's box, which is 15 pounds. Plug this into your calculator, you end up with $19.75. Answer is option letter H. All right, let's take a look at problem number 9. It reads, a computer chip 0.32 centimeters thick is made up of layers of silicon. If the top and bottom layers are each 0.03 centimeters thick and the inner layers are each 0.02 centimeters thick, how many inner layers are there? So a quick tip for you involving figures. Now, whenever you're solving problems involving figures, you want to give yourself a well-drawn diagram, completely labeled to assist you in formulating accurate equations. Okay, so if a visual is not provided for you and the problem has to do with some figure or geometric shape, you want to sketch it and label it as accurately as possible so that your equations will be correct. All right. Now, the computer chip we were talking about, a visual is given, provided for us here, but it's not detailed enough. Okay, so the microchip has a top layer, it has inner layers and a bottom layer. Can you see that here? The answer is no. So how would you assist yourself in organizing the different components of this problem in that chip, accurately labeling the layers? You can do this by drawing yourself a nice detailed diagram. Okay, so we're talking about the thickness of the chip or the depth. All right, so before we get started with setting up the problem, let's just talk about a formula real quick concerning unit length. So, formula that we'll be using. So the total length is basically given by multiplying the unit length times the quantity, okay? So we have multiple layers on the inner part. We have one on the top and one on the bottom. So let's go ahead and set up our equations. But before we do that, let's give ourselves a visual as we talked about earlier. So I'm going to increase the thickness of this so I can completely label it. So let's see what we have here. Starting from the top of the chip, all the way to the bottom of the chip, we have the bottom layer and we have the top layer. It's not drawn to scale, okay? And then we have the inner layer. Question, how many top layers do we have? We have just one top layer. This is the top. This is the bottom layer. And this is the inner layers, the multiple layers here. So we have just one top layer, okay? And how thick is it? It's 0.03 centimeters thick, right? So we have one top layer, we have one bottom layer. And how many inner layers do we have? We do not know, so let's represent it by x. Okay, let's declare the variable. Let x equals the number of inner layers. That's what we're solving for, okay? Inner layers. So using the formula right here, we're going to find the length for each component. We're going to multiply the unit length times the quantity. So we have the quantities down, one top, one bottom, x inner. The unit length for the top layer of the microchip is 0.03. Okay, so the total length of the top layer is simply 0.03. Makes sense since we just have one of that. Bottom layer, we have the length is 0.03. Also, it's the same size as the top layer. If you multiply that out, you get 0.03. What is the unit length of the inner layer? Each layer for the inner layer of the microchip is 0.02 centimeters thick. Multiply that, we will get 0.02x. Okay? So what is the thickness of the entire chip? The thickness of the entire chip, let's write it down. Thickness of the entire chip. Thickness of the entire chip is going to be what? It's going to be the top layer plus the bottom layer plus what? Plus the inner layer. Add all three together, that will give us the thickness of the entire chip. So based on the problem, if you look at this construction here and also in the problem, you're told that the entire chip, the length is 0.32. So we have 0.32 equals, the top is 0.03, the bottom is 0.03, and the middle chip is 0.02 times x. Okay, so we just solve this equation for x, and that will be our final result. Okay, so let's do it. We are now going to solve for x. Okay, so we have 0.32 equals 0.03 plus 0.03 is 0.06 plus 0.02x. Now this decimal is annoying. Let's get rid of it so it looks prettier. So we just multiply by all of them have two decimal places, so we'll multiply by 100. What does multiplying by 100 accomplish? It causes a decimal point to move two places to the right. Okay? So if we multiply by 100, this problem becomes 32 equals 126 plus 122x. Okay, this looks much better, right? All right, let's solve it. You subtract 6 from both sides, and that yields, what do we have? 32 minus 6 is 26, equal 2x. Divide both sides by 2. And our final answer, x is equal to 13. So the number of inner layers that you have are 13. 13 total inner layers. Answer is option letter A. Okay, option letter A is the answer for number 9. All right, number 10, last one in this review installment. The table below shows the number of cars Jing sold each month last year. What is the median of the data in the table? So one thing you want to keep in mind is a caution concerning finding the median is you always want to order the elements of your set in increasing or decreasing order first before you determine the median, okay? And don't forget, median just basically means the middle term. What's in the middle? If you're counting and you end up with one number in the middle, that's excellent. That's the median. But if you have two numbers in the middle, you just simply find the average of those two numbers, okay? All right, let's go ahead and solve this problem. So what do we do first? What we do first is we order the elements of this set. That's what we indicated just now, okay? So number of cars in ordered form, number of cars in ordered form is given by, let's see. So I'm gonna start, I wanna do it in increasing order. You could do it in decreasing order too. You end up with the same thing. So I want to keep track of my elements as I populate my set here. So let's look at this entire column, and let's look for the smallest number. Our smallest number is 13, so scratch that out, put the 13 down. No other 13s, 14, no, 15, we have 115 there, so scratch that out, put it here. So by canceling it out, I avoid making the mistake of abandoning elements of my set, okay? 16 is the next number. How many 16s do we have? We have just one 16. Put it down. 17. No. 18. No. 19. Oh, we have 2. 1, 2. 19. 19. All right. 20. 21. 22. 23. Wait a minute. 22. Haha. You have 22 there. 22. 23, now 24, 25. The next one is 25. There are two of them, 25, 25, 25, 25. Okay, next, 26. How many 26s? Just one. See, the numbers are dwindling. It gets easier the further you go. 27, we just have one. 28, we just have one. 29, we just have one. Oh, nice. Everything is canceled out. All right, so we should have 12. Okay, so whenever you have even elements of a set, you have to average the middle terms. Okay, so we're going to count to the middle and then we'll see what happens. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at the middle, we have two numbers. So if we count 1, 1, 1, 2, 2. You can use your two hands for this. 3, 3, 4, 4, 5, 5. And that's basically it. You end up right here. There's no term in the middle. So since we do not have any term in the middle, we have to find the average of the two terms that are next to each other. The two middle terms. Okay, we have to average those two, and that will be a median. This always happens when you have an even number of elements in your set. How did we have an odd number? Guess what? The middle term will be our median, and that will be the final answer. But since we have an even number of elements in this set, we have to do more work. We have to average the middle numbers. So the median is going to be 22 plus 25 divided by 2. Okay, so that we can use 47 over 2. I wrote 42. Sorry about that. Okay, 47 over 2, which is 23.5. That's your median. Okay, answer is option letter K. Thanks so much for taking the time to watch this presentation. If you found the contents beneficial to you, do give us a thumbs up. We appreciate the positive feedback. Do not forget to subscribe for updates to the remainder of this review series. If you have any questions about this, the contents of this video, or any math problems on the ACT test question in general, just place your question in the comment section below for support. More clips can be found on mathgoodserved.com. Thanks again for watching and have a wonderful day.